But the 180 minus 30, would that be different? Because obviously the graph shape is different.
Correct. And so what should it be instead of 180 minus?
Should it be 270?
No. You may not know it.
Is it 90?
No. For this one, because the line is in the middle, it will be 360 minus first. So,
Oh, okay.
So sine is 180 minus and cosine is 360 minus.
Right, okay.
So that's the error made by the student, and then write down the correct answer. So how would you get correct answer?
It'd be 360 minus 30.
Yep.
Which would be 330.
That's it. And so 360 minus 30 is 330 degrees. And so the two answers were 30 and 330. And that is x, that's called. The principal solution is correct. Yeah. And there we go, 30 and 330. Great, I think you're good for that. What is this one? This is tan. Let me just take a look at this. Yeah, okay, let's try this one.
Would the first answer for A be minus 63.4?
Yeah, sounds good. And how about B?
And then would this one be taking it from 90?
To get the second answer, is it?
Yeah.
No. Do you know how often the tan graph repeats?
Is it after every 180?
Yes. And so how could you get the second answer using that?
So that would be 180 minus the first answer? Or add?
Yeah, add. Because we're going over to this side.
Yeah.
So 180 plus first answer.
$116.6.
And that is 116.6 degrees. And let's see, so we wanted all the answers between 0 and 360. So this minus 63.41 is outside that range. So that won't count. So how can we get an additional answer?
Will we do it then from 260? Add the first answer?
That's right, yeah.
And that's 296.6.
296.6 degrees. So we'll just check. Yes. So and so now we've done sine, cos, and tan, and so this is kind of the complete set of all the things that you need to do to solve trig equations. So the first answer is always arc sine, arc cos, arc tan, depending on what it is. The second answer is the tricky one to remember. You can draw the graph to help you, but it's always going to be the same thing every time. Sine is 180 minus, cos is 360 minus, and tan is 180 plus. And then the same for all three. Every other answer is a previous answer plus 360 or a previous answer minus 360. And the one thing to watch for is if you get an answer like here, we got x equals minus 63.4. You don't discard that just because it's not in the range. You discard it at the end, but you keep it, you get additional answers. So you can add 180 to it, you can add 360 to it to get additional answers within the range. Any questions there?
No.
Okay, and every trig equation that you do, this is how you do them. You might have some extra work to do, like you did at the start, dividing both sides by 5, that type of thing. But that's it. I want to just see if there's any exam questions. I want to pick a tricky one here. Yeah, let's do question 3, part D. That's a strange one.
Right. Would we take it from whatever the answer for sine 15 is, the equivalent?
That's a good idea. Yeah, so what's that?
It's got minus, hang on, wait, 0.26.
Say it again, sorry?
It says 0.26.
Yeah, okay. And then what would you do next?
I'm not quite sure.
Just do it as normal.
The sine minus 1, the answer.
Yep.
That just says 15 again.
That's it. So theta is...
So then...
Oh, that's fine. Is that full marks?
Would there be some other answers? Because obviously the graph.
Yeah. So how can you get another answer?
Would it be the 180 minus 15?
Well done.
And that'd be 165 degrees.
That's it. And how do you know that there are no more answers after that?
Because of the shape of the sine graph.
Yeah, and basically to get additional answers you would just add on 360. So you'd get, I think, 375 for this one, but obviously if you add on 360 it'll be bigger than 360, and say you said up to the point 360. You could always do it and then you would just notice, oh yeah, that's outside, and even if you put it down they would just discard it. Great, that was a strange one. I think the important thing there is that sine 15 is just a number. Even if it's a strange number, it's just a number. If you have something like that, you can just put it into your calculator and get rid of it. Now let me see this one. Yes, okay, it's good. I just want to see if there's a similar one before I do it. Now let's jump. Okay, this is what an exam question looks like. Any idea how we do this?
Would we have to take the square root first?
Well done.
So that'll be the square root of 9, which is 3. And that'll be tan minus 1 to the 3.
Yep.
And that's 71.6.
Is that full marks?
No, because then we can do the second answer.
Mm-hmm.
We'll do 180, add the first answer.
Well done.
$251.6.
1.6. That's great. Is that everything?
Could we do it from adding 360?
You could. What would you get if you added 360?
That would be above the limitations.
That's right, because it's outside of 360. And in fact, you could keep adding 360 forever and ever. And like we saw before, you would still keep getting 9 over and over again. There is, however, a little trick to this one. X squared is equal to 9. You said you square root both, you get x equals 3. Is there another very similar number that when you square it, you also get 9?
-3.
Yes, and so do the same thing again for -3 this time.
Okay. Then that goes to minus 71.6.
Okay.
Um, 108.4.
Mm-hmm.
And then the next one would be 288.4.
That's great. 108.4 and 288.4. And yes, if you were to add on anything else, it would be definitely above. Yes. Great. So just watch out for that one. Something squared, tan of something squared gives you 9. You've got plus or minus.
Okay.
Any questions there?
No, not yet.
Great. Let me just check something. That's fine. Okay, so that was the exam question anyway. So solving trig equations. So that's kind of the beginning of it, the kind of year one stuff. Let's say it's first half of year one. So what would you give yourself for that? X a half or tick?
I think I understand that now.
Okay, that's great. Let me just take a quick look. I think you'll be fine. Let me just see. Yes. Ooh. Yeah. So then it goes more into the squared stuff. Yeah, I'll leave that for now. Okay, I'll just do a quick recap. Let's see. Yes. So in general, how do you solve an equation like this? Sine theta is equal to a half.
Yeah, we would just do the sine to the -1.
Uh-huh.
On both sides, and then you would think about getting the second answer, which is minusing it from 180.
That's it. How would you get the second answer for cosine?
For cosine, you would do it from. Would you minus it from 180?
That's for sine. For cosine?
Oh, 360.
That's it. How do you get second answer for tan?
For tan, you would do the 180 plus the first one.
That's it. How do you get a third answer for any of them?
Yeah, the plus or minus 360.
That's it. And yeah, so you've got the idea. This one you were good for. You started by dividing by 5. That was the important thing there. So these student questions you're good for. If you're ever stuck on part A, like trying to find the error, like sometimes I can't find what error they made, the easiest way is to just ignore what they did and just do part B, which is just figure it out, like just solve it. and
Okay.
then look at their one, and you can see obviously, oh yeah, that's where they went wrong. Tan, you're good for, yep. Just watch out for, hold on. So this one, why did we have to add 180 twice? Why was minus 63.4 not one of our answers?
Because it was outside of the limitations.
That's it, outside the range, so that's good. Let's see. So here, yes, sine 15, you were right. Just put it in the calculator and it gives you a number. That's the main thing there. Those are fine. And then we did the exam question. Why did we get a total of 4 answers for this one?
Because you can get the plus or minus 3 as the answer.
That's it. And so in the second half of the year 1 trig, you see more squared stuff. And so just watch out for that double